recording pause போட்டு மாஜா
pause பண்ணுங்க. Gentlemen, what a wonderful day. I am based out of Bangalore and the speaker is based out of Chennai. So beautiful weather in Bangalore. It's heavy rain. It's almost 9 days. There's a continuous rain and very chilly weather in Bangalore. I'm sure people from Delhi, especially from, must be hot there, heat waves in North India, but there are cold waves in South India. What a difference in climate, yeah. And as I was chatting there, this is our 9th webinar on various electrical subject. And today we are talking about earthing system, earth electrodes and chemical used in various aspects and an overview and applications about it. And as you all know, it's a very, very important subject. We take earthing systems for granted. You know, in many people relate electrical grounding with safety. And the most common conception is that if the system is grounded, it is safe from electrical shock. How far we are true in this? Earthing system is an electrical installation, is as important as a foundation in a building. With good earthing, your electrical installation reliability work for a long time. I'm also a student on this subject, and we have a wonderful speaker today who's going to talk. And he himself is kept on saying this is one of the best subject that he is covering when we compare to various other webinars that we had in the past. And I would like to introduce the company owned by our speaker, Mr. Gopakumar, Cape Electric. They are celebrating their 25th year in the business. Myself, Dominic, the founder of FSA, Fire and Security Association of India. I've been in fire industry almost 35 years now and been worked in various corporates. And we also have FOCUS, which is Forum of Critical Utility Services, which is consortium of all the professionals from the building services. And also I would like to thank CAVO, which is consortium of health organization, and FSIF, Fire Safety Foundation, and Vidyut for supporting this event. And I'm very glad to say we have over 1,200 participants for this program. And the subject is quite interesting. I could see very positive response for this webinar. And very soon we will be having a next webinar on learning from losses. You know, what are we learning from various tragedies that is happening, and everybody blames on electrical short circuit. So our next webinar, which is scheduled in June, we'll talk about learning from losses and what are the causes and consequences, and how much economy that we are losing just because we are not practicing rights electrical safety standards in India. So a small introduction about the CAPE. In 1998, such protection devices were new in India when CAPE installed the first SPDs for protecting industrial electronic system. DC combiner solution for solar PV were unknown once when CAPE delivered outdoor DC panel in 2002. In 2004, technical seminar on lightning protection not only helped industries in solving failures related to lightning, surges and earthing, but gave an in-depth knowledge about international standards. In 2016, TNS system with PME for industrial earthing without earth electrodes in soil, carrying safety and earthing a level above the existing practices. In 2019, global earthing system in interconnecting EHV, HV and LV and ELV system for large industrial and commercial installation and smart cities. Starting of the first project in India, solution with almost negligible touching voltage, and there are few mistakes in this reading. My apologies for losing certain words in it. Ultimately, in 2022, Solve, a digital platform, as a knowledge and process partner to ensure safe operations of low voltage electricity has been introduced. And today, Solve is there to assist every industry doing electrical testing, inspection, and certification of electrical safety audits. So Mr. Gopakumar will talk more about in his slide about Solve, how it's going to help each of the industries in India. So about Gopakumar is an electrical engineer, director of Electric. He's also one of the members in the working group of Indian and international electro-technical commissions, IEC, and the technical coordinator of Lightning Awareness and Research Center, LARC Trivandrum. Having more than 27 years of experience in electrical safety, lighting protection, and EMI, EMC of electrical installation. You must note that he has conducted more than 100 of site studies on failure in electronic equipment and presented papers more than 1,000 seminars and training and programs. As I know him, he is probably doing 2 in a week, either virtually or physically, and giving lectures to various industry captains in India. He also published an article about safety in various magazines and published the book, The Missing Link, the subject on electrical safety. I'm sure many of you would have heard this repeatedly in almost all the webinars, but it is my duty as an host to make sure that Gopakumar's profile is read, because he is doing such a wonderful job. He is the kind of charity in sharing the knowledge is wonderful, well appreciated all over India. So I now invite Mr. Gopakumar to take over from here. Over to Mr. Gopakumar.
Thank you very much, Mr. Dominic, for the nice introduction. So as usual, I think we are back after 1 month with the today's webinar. Let me share my screen. I don't know whether the screen is shared or not. No.
The desktop has been shared. So.
Yes. Who can share? Only host something? No. It's my mistake. Okay. Yeah, I think now it's visible. The screen is visible.
Yes.
Showing of Vidyut Surakshit Bharat Abhiyan, which was a program campaign on electrical safety, which we started last year. After the 26th of June, every year is celebrated as Electrical Safety Week, starting from 26th of June, 1 week. So last year we started this program, and we are actually reaching almost 100 programs in 1 year, not even 1 year, before 1 year, almost 11 months. All the participants can find out the information from this particular website, vidyutsuraksha.com. Plus a lot of blogs and technical details are also there in this particular website. Why I'm showing this is actually, as Mr. Dominic was saying, every day I am making weekly 2. It's actually not weekly 2, sometimes weekly 5 or 6. Today in the afternoon we have a session from 3 to 5 o'clock. Tomorrow 11 to 1 o'clock, a lightning protection program by Dr. Nagabhushana, the retired scientist, the retired chairman of high voltage engineering from Indian Institute of Science. Then tomorrow afternoon again. So this week, in next 2 days, today and tomorrow itself, 4 2-hour sessions. However, anyway,
you would have lost the number counts. How many are doing? When you said 1,000 papers, I think you have done more than that. Amazing to have so much of energy and so much of patience to do this, free knowledge to everyone. Hats off to you, Mr. Gopakumar.
Thank you, thank you, thank you. Actually, nowadays I stopped counting because counting is not important. So, good morning, ladies and gentlemen. Today we are going to discuss about a subject which is an interesting subject on electrical safety, earthing, especially on earth electrodes. So, earth electrodes in soil, what are they and how they are going to, chapter 17, don't look at that because this was a part of my large presentation. Each section is 2 hours. So now today we are going to discuss about the earth electrodes in soil. Let me switch off the video for better connectivity. Now, the first point, almost every electrical engineer, nowadays not only electrical engineer, almost everybody, those who are working in a building, including the tenants, including the owners, believe that a good earth electrode will solve all the problems, electrical safety problems. So whenever there is an issue, whenever there is a shock or a fire or arcing or sparking, the first job with which people do is to improve the earth electrode resistance. So today we are going to discuss whether it is really necessary or not. Now, the existence of earth electrode, all of you know very well that we were using a protective device in low voltage engineering called as ELCB, Earth Leakage Circuit Breaker. During the earlier days, nowadays I think ELCB is not even available in the market. But during 1970s, 1980s, 90s, or even 10 years back, ELCBs were quite common in the market. What are those ELCBs? Imagine I'm just showing you a transformer, a 3-phase connected to some equipment. There is a neutral as well, and I am showing a TT connection where the consumer premise is connected to an earth electrode in soil. And imagine in this particular case, there is a leakage current. One of the phase, the insulation has degraded. As a result, there is a leakage current. Then what happens is the leakage current will flow through the earth wire. It goes to the earth electrode. It goes back to the source, it flows through the earth electrode of the neutral, then finally it will reach the neutral. So basically the fault loop is made from the fault through the earth electrode, through the soil, through the neutral earth electrode, through the winding of the transformer, through the phase conductor. So you have a closed loop and a current is flowing. And
sorry, Gopakumar, slides are still that on the seminar one, what is there on the screen. So okay, if you can close and do the PPT, that would be better.
Yeah.
Yes.
Is it okay now?
Yeah, absolutely.
Now, is it changing?
Yeah.
Changing. Okay. Thank you. So, yeah, sometime troubles. Now, the fault loop, imagine on the left side, I'm showing a transformer, a 3-phase connection. There is an equipment or probably an installation. There is a leakage current in the installation. The current goes through the earth electrode to the soil, and it returns back to the source through the earth electrode at the of the neutral of the transformer. This is called as TT system. Now, what you should understand is the principle of operation of earth leakage circuit breaker. Earth leakage circuit breaker measure the current which is flowing through that particular wire, earth wire, and it is this measurement is connected to a sensing mechanism and a mechanical switching operating device. And what this device does is, whenever the current through this wire is more than the limit, let's say for example 30 milliampere, whenever the current is more than this 30 milliampere, this device will sense that current which is 30 milliampere and it disconnect the supply, or your ELCB will trip. As soon as your ELCB trips, the leakage current is gone, the shock hazard is gone. This is the simple method of operation of an ELCB. Now, what you should understand is in an ELCB, this earth wire and probably this earth, the earth connection to the earth electrode is very much important. If we miss this particular connection, then actually we are in trouble, because there is no current flow to the earth electrode, and probably if a person touches, he get a shock. So this is a dangerous situation. Now imagine the ELCB is not working, there is a leakage, and a person touching, he will die, because the ELCB must trip by sensing this particular current. And in case of any change in this sensing of this particular current, there is a trouble. Earth electrode and this connection is very much necessary. For example, imagine in your installation, if you have made a wrong connection means one of the equipment, you took one more earth wire and connected it to another part of your installation, probably to somewhere else. If there is a leakage current flow through an alternate path, actually we are in trouble, because we are disturbing the disconnection, the mechanism of the ELCB. As a result, we don't know whether during leakage ELCB will trip or not. So basically, making this kind of a mistake, the second connection which I am showing, or I'm showing on the pointer, this is a problem. But what you should understand is ELCBs are nowadays outdated. Nobody uses ELCB in the market, or I don't think that it is available in the market. Nobody uses, except some old installations. Nowadays, ELCBs are not there. Now, what you should also understand is for an ELCB, proper routing of the earth conductor and the earth electrode was important. However, currently, what we use for earth leakage protection or earth fault protection in a TT system is an RCD, a residual current device. What does the residual current device does? It is measuring the current in a junction. It is measuring the current of all the live conductors, all the current carrying conductors. Whenever there is a leakage of current, actually the current is escaping from this circuit. It is escaping from this junction. This particular device measures the current which is escaping from the junction, say for example 30 milliampere, and it trips. Now the difference between ELCB and RCCB, you must understand that. Imagine in an RCCB there is no earthing. Imagine there is no earthing. The RCCB will not trip. The body of this panel board will be live. As soon as the person touches, since the current starts flowing through the body of the person, immediately the RCCB will trip. So from this, what you should understand is, if you are using an ELCB, connection to the earth electrode, proper connection to the earth electrode, and the earth electrode itself is important in order to ensure disconnection of the supply. Whereas in case of an RCCB, even if the earth electrode or the earth connection is not at all available, the person will get a shock and the MCB trips, or the RCD trips. RCDs can be used as a protective measure against direct contact. Direct contact means, even if somebody touches the live part of, let us say, where I am scrolling, then immediately the RCCB trips. Whereas ELCB, it is not the case. So the use of ELCB and earth electrode was very much important during olden days, especially before the introduction of RCCBs. After the introduction of RCCB, of course, earthing, protective equipotential bonding is very much necessary, mandatory. But imagine in an installation, you forget to connect to the earth electrode. Still you are safe, because a person who is touching accidentally on a live conductor, he may get a shock, but before the shock is hazardous, or before the shock is serious, the RCCB trips. In IS3043, you can see two pictures. One is how to make a typical way of making earth electrode in soil, a vertical pipe and a plate. to my knowledge or to my information, actually these two are the pictures which is spoiling the whole knowledge on earthing. After seeing this picture, people think that, aha, earthing is like you put a pipe, you buy salt and charcoal, you put it on, you dig a hole and you put a pipe, fill it with salt and charcoal, then make a chamber and all these things. There are government buildings. Last week I was there in a railway station. Outside the railway station, I could see at least 20, 30 chamber. This on the left side, you can see the chamber. Each chamber is about 200 millimeters above the soil level. This was actually it was spoiling the entire place. So basically, people think that the earthing is as per these two pictures. I am so sorry to say that these pictures are only giving a typical example of making an earth electrode in soil. Whether you need an earth electrode in soil or not is explained in the standard, and most probably in a TN system, earth electrodes are not very much mandatory. In TT, of course, yes, we will see it later. As a result of these pictures from the IS standard, which was very much an old standard, 1960s or 1970s. As a result of these two pictures, invention started. People started coming out with different earth electrodes. I have clean earth, computer earth, digital earth, analog earth, all these different names came into existence in India because of these two particular picture. People started like these are like innovations of earth electrode. Unfortunately, wrong innovations. The second part is earth farm. There are places where so many earth pits are made separate. Each one is for a typical application, like one is for DG neutral, or two numbers are for DG neutral, two are for DG body, two are for transformer neutral, two are for transformer body, and all these things. I call this as earth farm, an useless earth farm. Similarly, modern buildings. 2 weeks back, I was in a data center and I was actually laughing after seeing the number of earth electrodes. There were about 220 earth electrodes all around. So you actually require one, and there are 220. I don't understand why people are using so many numbers, and these are the reasons for accidents. So as a result of the picture from the IS3043, we started making the mistake, and these mistakes are at its peak nowadays. This video, I got the video saying that the MCCB didn't trip. There is an UPS and the MCCB didn't trip during this incident. I really don't know whether this incident is due to, you see, there are some chambers you can see. There is 1 blast, 2 blast, 3 blast, and the 4th one. So I really don't know whether this is earth electrode or not. But somebody sent to me with a question saying that this has happened, but my MCCB didn't trip. Then I asked whether is it due to an electrical fault. They told yes, but I really don't believe that this is a blast from the. This is not like this is not an earth bomb, So I don't think that it is because of an electrical fault. But still, I'm not 100% sure. But the way we are following electrical safety in our building, even if this kind of an earth bomb happens, you don't need to be surprised, because each part of the building is connected to separate earth electrode. Then the joints are corroded, and all these such explosions. If somebody asks whether explosions are possible, I would say yes, of course. But I don't know whether this case is due to that kind of an earth electrode or not. So the first evil which is against the electrical safety in India is the story called as 2 for neutral, 2 for body. This is the first safety violation. I repeat every time in my presentation because it is the most important violation which is happening in India. Now let's look at what exactly is this earth electrode resistance. I'm just showing a resistance RE generally RE is the earth electrode resistance. The symbol is, from point number 1 and 2. So point number 1 and 2, from here to here, there is the resistance. And where is the point number 2? Point number 2 is the infinite earth. Earth is infinite. It is zero potential. This is the belief, or this is, the way we do things. Now, one moment. Some of the presentations slides are not working. One moment. Yeah, you have the resistance R, and whenever there is a current flow through this particular resistance, you know very well there is a voltage drop in that particular resistor. Let us say, in a typical case, whenever there is a current flow through this particular resistance, there is a voltage drop created. Now, if we put it in an actual situation, you can see the earth electrode number 1, the point at which you are connecting is the point number 1. Then you have the earth electrode in soil. Then you have, like a sphere, there is an area in soil, and your infinite earth is point number 2, which is far away from the earth electrode. Nobody knows how far. We can only make some calculations and take some approximations. So basically, the electrode resistance which we are saying, it is, now you can see here, there is an earth electrode, there is an influencing area around the earth electrode, and basically the resistance RE which we say, it consists of 3 factors. Number 1, the resistance of the earth electrode itself. Imagine you have a 3-meter rod having some milliohms or some micro ohms resistance. The contact resistance between the electrode and the soil. The third one is the resistance of the soil from the electrode surface outward in the geometry setup for the flow of the current outward from the electrode to infinite earth. So the third factor, which is nothing but the soil in between the earth electrode and the infinite earth, these 3 factors are going to influence the resistance RE. Out of these 3 factors, the first one, resistance of the metal electrode, is actually immaterial because it's negligible. The second point, the contact resistance between earth electrode and soil, even though we generally say that the first 2 are immaterial, actually sometimes the contact resistance also matters. How does it matters? For example, if you have earth electrodes in rocky areas, you dig a hole and you filled the hole again with some stones. Under that condition, the earth electrode is not in good contact with, or the contact voltage or the contact resistance is high. It is not in good contact with the soil. Under that condition, number 2 is also a significant value, but generally the first 2 are neglected. The most important point, or the most important value which is influencing the final result, is the soil resistivity around that particular area, which is called as the sphere of influence. IEEE 142, I had explained it very well. You can also download the standard, you can read it. Now explanations are given in IEEE 142. I don't want to read it much into that. They have put a 10-meter rod, that means a 3-meter rod, and then try to measure the electrode resistance and its influencing area. One moment, I think one of these, yeah. And the influencing area, it is like this. Each electrode has got multiple, it is like, multiple spherical areas which is going to influence this particular rod, the resistance of this particular rod. I have an equivalent circuit. I will show you. It is like, you see the resistance of 1 sphere, the resistance of 2, 3 spheres, 4 spheres, and finally n number of spheres. The resistance connected something in this kind of a fashion to the infinite earth zero potential is combinedly, we can call this as the resistance RE. Whenever there is a current flow, of course, there is a voltage in that RE, which we call as the voltage gradient. So At the point of the fault, whenever the current starts flowing, the voltage is the peak, and this peak is equal to the operating voltage of the circuit which is going to be in fault. Let us say, for example, the fault is created by a 230 volt line. A 230 volt line is in touch with the earth. In that case, the peak of the voltage is 230 volt. I repeat this again. Whenever there is a fault in 230 volt, the peak of the voltage gradient is only 230 volt. Why I made this statement again is, I used to get calls from users. They say that we have to design an earthing system. Fault current is 50 kiloampere. Soil resistivity is 50 ohm meter. So you please help us in making an earth grid or an earthing system of 50 kiloampere. Now, once when I ask what is your demand, they say the touch and step potentials must be lesser than 2 kV, 1 kV, or 600 volt or some voltages. But practically what happens is, if this, and most of these inquiries are coming for application like low voltage, 230 volt. Actually, in 230 volt, I would say, of course, there is a voltage gradient, but the within half feet, the majority of the voltage is over. The shock is over. So basically, in 230 volt, this I would say not very much important. Instead, you make protective equipotential bonding. Now, however, for a high voltage system, of course, depending upon the operating voltage, the voltage is fatal. As a result, step and touch voltages can happen. Now, for example, you think that this voltage gradient is made at a distance of, let us say, 10 meters. If somebody asks, do you think that in a typical place, the 100% earth resistance is within this, the sphere of influence is 10 meters? Technically, it is not. So in the IEEE 142, you can find this particular table. They started measuring the resistance of the earth electrode with respect to the distance, and approximately a 3-meter rod within 7.6 meters, the 100% value is achieved. But the measurement is still carried on at a longer distance, 30 meter, 300 meter. Still lower resistance values are possible, but the increased, the influence of this area is not significant with respect to the increase in the distance. So 270 meters increase, only, about 15% improvement. So these are considered as insignificant. As a result, we think that the 100% is the RE value, which is received within an area, a typical area of 7.6 meters. This is only an example, but from place to place it varies. It depends on the soil resistivity, basically. For high voltage application, anything more than 1 kV, of course, you have the step and touch voltage problems, which is explained in the IS3043. Also in the EN 50522, you can find the problems explained, such as the touch voltage, step voltage, and transfer potential. Transfer potential, I just explained here. You see, there is a transformer here. There is an earth electrode plus earth grid. Whenever there is a fault current flow, you see the potential of this particular point is at a very high level. You have a touch voltage problem here. You have a step voltage problem here. Now the wire is also connected to a remote place. Let's say, for example, the armoring is connected to a different place. In that particular case, the armor also will carry the potential, and at a remote location, there can be a transfer potential. So for high voltage application, we are supposed to take care of step, touch, and the transfer potentials. Anyway, our subject is mostly into low voltage. Now, this is only an equivalent circuit which I am trying to explain what will happen. You have a source, you have the line which is faulty, and at the place, faulty in the sense it is in touch with the earth. And now you have the RE here, which is going to create a voltage gradient at the place of the fault. And near to the neutral, because the transformer neutral is also connected, near to the neutral, there is another potential, the voltage gradient created. Now, what you should always understand is, I am taking a red color line if there is a metallic fault return path, if there is a metallic fault return path, this red color, if there is a metallic fault return path, actually the fault current, the majority of the fault current will flow through the metallic fault return path. But now, for high voltage substations, where the distance between the source and the secondary switching stations are far away, maybe tens of kilometers, hundreds of kilometers, then this fault return through the metallic conductor probably is less, and probably in some cases the low resistance of these earth electrodes are practical. So basically what you should understand is voltage gradients are created at the place of the fault as well as when the current is returning back to the neutral of the system. Earth electrodes in parallel. In order to reduce the resistance of the earth electrode, a technique which is used is to have multiple earth electrodes in parallel. Remember, each earth electrode has got a sphere of influence. And if the second electrode is away from the sphere of influence of the first one, like the one in the picture, then you get a better value. Earlier days, we were always saying that 2L, the distance between two earth electrodes are 2L. Imagine the L, length of one vertical electrode is 3 meters, then the distance is ideally, if it is more than 6 meters, then you get a better value. But nowadays standards, the availability of space and other problems are coming. As a result, the standards even started accepting at least L is required, is necessary. That means if you have a 3 meter rod, the next rod must be at least 3 meters away. Then only you can get better values. Now, for public electricity distribution, especially when you go for a TT system, there is a question whether the high voltage side and low voltage side is connected together or separated. So under certain conditions, the electricity supply companies, not in India, but in abroad. In India, I would say the electricity supply companies, most of them, to my knowledge, doesn't have this particular knowledge. In Europe, or especially in UK, in a TT system, the high voltage earthing and the low voltage earthing is separated for certain application. And if this separation is made, at least imagine this one is the first one where I am drawing. If this is the earth electrode of the transformer, the second one is made, the neutral earthing at the secondary side of the transformer is made at the first post, at least 10 to 15 meters away. So higher resistance or the higher distance is making a better value. Otherwise, multiple earth electrodes will not reduce the earth resistance if they are placed closer. But most of the electrical installations, if we go practically visit, earth electrodes are connected quite nearby. 3 meter rods connected in every 3 meters, or connected, put in every 1 meter, not 3 meters, sorry, 1 meter. Now to our subject, earth enhancing compounds. What are they? Will they really help in reducing the earth electrode resistance? Do we need that kind of a performance is today's discussion. We have actually made a picture which attracted a gentleman who is trying to pump some electricity through a pipe. Whether is it required or not is the question of the day. Now for low voltage consumer premise. For consumer premise, imagine you have a house or you have a small industry where you are getting 230, 400 volt line. And if you have a TNS system, industrial and commercial application, TNS system, earth electrode resistance is immaterial. In the sense, if the earth electrode resistance is 10 ohm or 50 ohm or 100 ohm, actually it doesn't matter. TNCS system for public distribution, earth electrode resistance is immaterial. TT system for public distribution at consumer premise, if you are using a 30 milliampere RCD, of course, the resistance, what is recommended in the standard is 1666 ohm. You can see it, I think, in table 14. If you use a 300 milliampere RCD in a TT system, then the earth electrode resistance is 166. Of course, these values are a little bit higher. Probably it is not the earth electrode resistance, it is actually the impedance of the entire loop. Now for low voltage public distribution, for the utility company, the first one for LV system, this is applicable for a consumer premise if you are an user of electricity, whereas this one is applicable for the electricity supply company. If they go for a TN system, and if they go for HV and LV earthing separate, that means the transformer HT side and the neutral earthing separate, then high voltage side, earth electrode resistance is important to protect the transformer. Otherwise, the transfer potential during a fault at the HT side of the transformer may kill the LT winding. So for the public distribution company, sometime if they go for HV and LV earthing separate, then the HV earth electrode resistance is important. In case of a TT system, again for the public distribution company, if they go for HV and LV earthing separate, the HV earth electrode resistance is important to protect the transformer. If they go for HV and LV earthing together, that means the HT side and the LT side earthing is connected together. In that condition, earth electrode resistance is important to protect the consumer premise. Consumer premise means our houses. What does this mean is, electricity can be supplied from the transformer under several methods, TNS, TNCS, TT and all. If the distribution company is using a TN system, and if they wanted to make HT and the LT, earth electrodes separate, then of course the HV side earth electrode resistance is important. Number two, if they go for TT system, if they wanted to make HV and LV separate, in order to protect the transformer, earth electrode resistance is important. Now, if HV and LV is together, in order to protect the consumer premise, earth electrode resistance is important. But if we look at the from the point of regulation, actually we are supposed to follow TN system and not separate, connected together, so that everything is safe. I will explain it later. Now for industrial system, industrial and commercial system, what do we mean by industrial and commercial system is, you have a transformer either close by, or you have a transformer your own. You have a 11 kV bar 400 volt transformer, or you have a 33 kV bar 400 volt transformer. So in that particular case, if you go for a HV and LV interconnected system, that means the HT side and the LT side are interconnected, and your LT is a TNS system, this is the recommendation of the standard. In that particular case, earth electrode resistance is immaterial, means you don't need to measure, or you don't need to have an earth electrode of 1 ohm or 5 ohm or 10 ohm or 20 ohm or whatever it is. That is immaterial. Now for lightning protection system, if type A, lightning protection system, earthing is important. In fact, electrodes in soil are important. Lightning protection system earthing is classified into type A and type B. Type A can be a vertical or a horizontal conductor. I have a picture I will show you later on. If you go for a type A earthing, one of the technique which is adopted is at 10 ohm resistance. So if you practically look at today's modern building where you have your own transformer, or you have a transformer very close by, the only place where you wanted to have a 10 ohm resistance is an earth electrode for the lightning down conductor. If you go for a type A earthing, if you go for a foundation earthing, or if you go for a ring earthing, then this value is also immaterial. Now, in a type A earthing, earth electrode may require an earth electrode resistance lesser than or equal to 10 ohm. We will see this later. This is the only place where you need to have a specific value of earth electrode resistance in an industrial or in a commercial premise or in a consumer premise. Now, how to calculate the earth electrode resistance? In IS3043, lot of formulas are there, complicated formulas. But nowadays, these formulas are being simplified. IS732 has got very simplified formulas like this. R equals rho by L. You know very well that rho is the resistivity of the soil in ohm meter. L is the length of a pipe or pipe or a vertical conductor. The second one here in this particular case, L is the length of a horizontal conductor, and here in this particular conductor, this is this case, third case, perimeter of the plate in meters. The fourth case, if you have a buried metal pipe or a structural part, then you can also find out the earth electrode resistance. A simple calculation. Imagine you have a 100 ohm meter soil and you have a 3 meter rod, then the earth electrode resistance is 100 divided by 3, approximately 33.3 ohm will be the resistance of your earth electrode. If you have a 100 ohm soil resistance and if you have a 100 meter conductor horizontally, then the resistance is 20 ohm. So by making these simple calculations, you can find out the resistance of the earth electrode in soil. Technically speaking, for low voltage application, you don't need to make so much accurate calculation because it is not going to help you. Because even if the earth resistance is 3 ohm or 30 ohm, doesn't matter. So these are included in the upcoming in the IS732. Now, a technique which is used to reduce this earth electrode resistance is to have something in the soil surrounded by the earth electrode, the area which is surrounding the earth electrode, which may influence and reduce the resistance of the earth electrode. Now, first what we should understand is what is this soil resistivity? Soil resistivity depends on the type of soil. I'm sure most of the electrical engineers knows this particular table. So the resistivity probable value ohm meter depends on different kind of soil. You can see the values 5 ohm meter, 20 ohm meter, 50 ohm meter, 300 ohm meter, 2000 ohm meter, like that. What you should also keep in mind is the corrosion. In soils where you have low soil resistivities, let us say, for example, less than 25 ohm meter, in that case, the soil is severely corrosive. On the right side, you can see here, severely corrosive. So this soil is severely corrosive. That means in places where the soil resistivity is less than or equal to 25 ohm meter, you have to be very careful because the earth electrode can be eaten away very fast. It can corrode very fast. Then moderately corrosive, mildly corrosive, and very mildly corrosive. So anything above 100 ohm meter is mildly corrosive. What you should understand is, of course, a low soil resistivity offers a low earth electrode resistance, but it increases the corrosion of your earth electrode. I took this table from the EN 12501 part 2, which is talking about the corrosion factors and the pH values. So here, you can see here, this one is the resistivity of the soil of some kind of material or any kind of material which is in and around the earth electrode. If the resistivity is less than 10 ohm meter and if the pH value is something here, anything less than 10 ohm meter is more corrosive. What does it mean is, imagine you have a 100 ohm meter soil and you put an earth enhancing compound of, let's say, 0.2 ohm resistance in and around that particular earth electrode. 100 ohm meter, probably you are getting 10 ohm resistance. With the additional material, you may get 8 ohm resistance. But this 2 ohm improvement in the resistance actually is degrading the life of your earth electrode, because the material which is in and around the electrode is actually highly corrosive. As a result, the chance of corrosion of your material is high. So any earth enhancing material which is having a resistance less than 10 ohm meter lead to accelerated corrosion of the metal electrode. Now, please understand that the corrosion is equally important because you are installing a metal in soil, and this metal should give a life of at least 10-15 years or even 20 years. But with the earth enhancing material, probably 3-4 years, the whole thing is gone. Now, the other influencing factors. The other influencing factors are, one moment, please. Yeah, the other influencing factors are, now you can see here, the moisture in soil. Moisture in soil is a very, very influencing factor. Now here on the x-axis, you can see the percentage of the moisture up to 70%. Now you see here, once when the moisture is lesser than 10%, then the resistivity of the soil is increasing drastically. Imagine a soil where the moisture is zero. If the moisture is zero, of course, nobody knows what is the peak value. So moisture is an important factor in the soil resistivity. In dry soil, resistivity is extremely high. How much extremely? Probably 10,000 ohm meter. Below 0 degrees centigrade, resistivity increases tremendously. In IS3043, clause 13.7 has written, below 0 degrees centigrade, the water in the soil begins to freeze and introduces a tremendous increase in the temperature coefficient, so that as the temperature becomes lower, the resistivity rises enormously. It is therefore recommended that in the areas where the temperature is expected to be quite low, the earth electrode should be installed well below the frost line. How much deep well below the frost line is a big question. We will discuss it later. The second part, which is influencing the earth electrode resistance or the soil resistivity, is the salt content, percentage of salt in the moisture. You can see the particular graph. The third factor is the length of the earth electrode in soil. Of course, the diameter of the earth electrode is also a factor, which we will discuss the last point. Now, in a typical 100 ohm meter, 25 mm rod, you see here 25 mm rod, 100 ohm meter. From this table, we will see that if the length of the rod is 1.2 meter, you simply calculate 100 divided by 1.2, it is approximately 90 ohms. So 2.4, 45 ohms, 3.6, 25 ohms, 4.8 meter pipe or a rod 4.8 meters long in soil will give a resistance value of 23 ohms. So these tables are also there in the IS3043. This particular table, it is actually derived from the IEEE 80, which is explaining the temperature, moisture, and the salt, the effect of temperature, moisture, and salt in a typical case. Now, on the left side, you can see the soil resistivity of the soil. And the curve number 3 is for temperature. The curve number 2 is moisture, and the curve number 1 is salt. More than the salt, moisture, if the soil doesn't have moisture, of course, the value is too high. If the temperature is minus, then the problem is even higher. So one of the paper published by Dr. Jan Meppeling, he is a scientist from Germany, and he has his specialization is in the area of safety. He has published a lot of technical papers, and one of his journal he has published a report. I am also going to he allowed me to republish that particular journal, which I will be putting in our blog very soon. So please follow the blog so that you can download this information at free of charge. So what you should do, from this paper, what we are trying to find out is, you see, in winter and in summer, there is a drastic change in the resistance or in the temperature. So basically, in countries where you have sub-0 degrees, let's say, for example, minus 10 degree, minus 15 degree for longer durations, the soil is really dry. There is no moisture and the temperature is very low. Under that condition, the earth electrode becomes a little bit risky. Influence of frequency, again from the same paper. I don't want to explain it much because we have so many other points to discuss. Now, an earth electrode in soil Please look at the picture on the left side. So this one is a D. D means you have an earth electrode and you have earth enhancing compound all around the earth electrode. So the D is nothing but the diameter of the earth electrode, including the earth enhancing compound. Under that condition, the length of the vertical rod in meter and earthing resistance, the final value, I have put it in a table. In a typical case of, this is the soil resistivity considered here, 10,000 ohm meter. If you have a 10-meter rod, the resistance is 800 ohms. If you have the earth enhancing compound 200 millimeters all around. If you have the earth enhancing compound 1000 millimeters, that means 1 meter all around the earth electrode, 1 meter is of earth enhancing compound, then you get a value of something about 520 ohms. The same increased rod length, the resistances are given. Similarly, a lot of time people ask a question whether the resistance of a earth enhancing compound, does it really influences the resistance of the final RE value? Again, from the same paper, they have made a research on a backfill compound of 0.4 meter, backfill compound of 2.3 meter, and backfill compound of 100 ohm meter. So different backfill compounds are used for an earth electrode, constant diameter, and you can see here the final values for all of these earth enhancing compounds with different earth electrode, the resistivities, finally the values, the final resistance values are similar. So here the conclusion is the resistance of earth enhancing compound do not have much influence in the final electrode resistance. Why I put this into the presentation is, lot of time customers call us, I need an earth enhancing compound of 0.12 ohm meter. Somebody asks, I want an earth enhancing compound of 0.2 ohm meter. Actually, whether the resistivity of the earth enhancing compound is 1.2 ohm meter or 0.12 ohm meter or 12 ohm meter, it actually doesn't matter. So you can see here in the table, a backfill compound of starting with 0.4 ohm meter to 100 ohm meter, the final result is almost the same. There is no big change. The conclusion is the resistance of the earth enhancing compound actually doesn't matter. A study is already also made with different soil resistivities, 500 ohm meter, 1000 ohm meter, 5000 ohm meter, and 10,000 ohm meter. The diameter of the filling material, the earth enhancing compound, is 10 centimeter, 20 centimeter, and 50 centimeter. The resistivity of the backfill compound, 1 ohm meter, 10 ohm meter, 100 ohm meter, like that, the filling material, different resistivities. Now, what you will see is very important, probably the most important information which I wanted to give to you today. If the soil resistivity is, let us say, for example, 0.5 ohm meter, the resistivity of the earth enhancing, not the soil resistivity, sorry, the resistivity of the earth enhancing compound is 0.5 ohm meter. And if you have 100 millimeters of 4-inch or 100 millimeter area filled with this particular material, then the improvement of the soil final RE you are getting is about 22%. What does it mean is, in a typical soil without earth enhancing compound, imagine the resistance which you are getting is 10 ohm. With earth enhancing compound all around the electrode 100 mm, you get 22% improvement. That means the value is something about 7.8 ohm. Instead of 10 ohm, you get 7.8 ohm. But remember, you should put 100 millimeter all around the electrode. Now, if you fill the electrode 200 millimeter, then the improvement is 32%. If you fill with 500 millimeter, that means almost a half meter all around the earth electrode, you get about 46% improvement. So basically, the area all around the particular electrode where we are going to put the earth enhancing compound is a serious factor which is influencing the final resistance. Now, here you see the resistance of the earth enhancing compound 0.5 ohm, 1 ohm, and 10 ohm. Is actually the resistance of the earth enhancing compound doesn't matter. With 0.5 ohm meter, the same value. 1 ohm meter of the earth enhancing compound, the same improvement. 10 ohms of the earth enhancing compound, the same value. So what is important is the resistance of the earth enhancing compound is not very much important, but the area with which you are filling is more important. Now, another case, soil resistivity 500 ohm meter, earth enhancing compound of 100 ohm meter, then the improvement is 18%, 200 mm filling 25%, 500 mm filling 35%. Soil resistivity of 1000 ohm meter, resistivity of the earth enhancing compound is 100 ohm meter, then the improvement is something like this. So basically, what I wanted to tell you is if you are filling 100 millimeter, why I stress this 100 millimeter again is most of the electrical installation, we take a hole of 4-inch, 100 mm, put a rod inside and fill this gap with the earth enhancing compound. So typically it is about 100 mm. So if you put an 100 or if you fill up this earth enhancing compound at a dia of 100 millimeter, the improvement in the RE value is something about 20-22%, 18 to 22%. That's all. Don't expect that, without earth enhancing compound in normal soil, I get 10 ohm, but the supplier say I have a magic compound, and if you put my magic compound, you will get 1 ohm. This is impractical or impossible. Even with a magic compound, in normal condition 10 ohm, the best you can get is about 8 ohms if you fill 100 millimeters, something like this, 100 millimeters. So these reports will be published in that particular blog, which I will give you later on. Now the same, I have made a comparison. Imagine the soil resistivity of 500 ohm meter. In normal condition, a 20 mm rod 9 meter long, 20 mm rod 9 meter long will give almost 62 ohms RE resistance. If you fill all around the electrode 100 millimeter dia earth enhancing compound, you get about 48 ohms. If you fill all around the electrode 500 millimeter dia, you get a value of 33 ohms. So practically filling the whole area with the 500 millimeters of the earth enhancing compound will be a very expensive measure. Instead, you can add 2 more earth electrodes a little bit away and you get the same result. So basically, these materials also have a lot of limitations. Don't think that a chemical will solve all my problem. No, it is not like that. The chemical, depending upon the area which you are filling, 100 millimeter average, you get about 20 or 22% improvement, irrespective of you are using X make or Y make. Now, the alternate method is, you can see here on the table, on the left side, you have a normal rod. The soil resistivity is 5000 ohm meter, a normal rod, 20 mm rod, you get a resistance of approximately 635 ohm. Now, all around the same rod, a 50 centimeter backfill compound is used. 50 centimeter, 500 mm, almost half meter of backfill compound is used, and the backfill compound is having 2 ohm meter. Under that condition, or if you use a solid round conductor of half meter, 50 centimeter, which is practically not possible, or if you use a cage, the result are same. it also means instead of filling up this area with the earth enhancing compound, if you put a 100mm pipe, or if you put a cage, something like this, a cage of 100mm, the result is going to be same, because it is improving the area basically. So instead of backfill compound, the same result is achieved by increasing the diameter of the electrode, something like this. The earth enhancing compound in this picture where I am moving the cursor, here the diameter, the virtual diameter is increased by the earth enhancing compound. In the second case, the physical dimension of the pipe itself is equal to a large area. In the third case, a cage is made. So all the three cases, the result is same. Now, as an alternate to earth enhancing compound, these techniques also can be used. The advantage of these two techniques, like a solid pipe, a larger diameter solid pipe, or a cage, is earth enhancing compound actually increases the corrosion of your electrode, whereas these two, the corrosion is influenced only by the soil, not by the earth enhancing compound, because earth enhancing compound actually accelerates the corrosion due to its low resistivity. So in these two cases, practically you can have higher, longer life because the corrosion is immaterial. The same paper which I will put on it's a research paper, internationally vetted paper. The same paper also explains a horizontal conductor. A horizontal conductor you can see here with a tape. Three or four different manufacturers earth enhancing compound, and these earth enhancing compounds, you can see the resistivities which they are offering. For example, one of the make, for example, is something about 1 or 2 ohm meter. With the different resistivities, the same results are published, and I just put it on the table. Resistivity of earth enhancing compound, if it is 0.5 ohm, 100 sorry, this is not exactly correct. This is not 100 mm. I think yesterday I changed the table, but it didn't get changed. So basically, from the picture, what you can find is the earth enhancing compound. Let us say here, one of the make. Let me draw it one moment. See, this particular case, the earth enhancing compound is something about, let us say, 20 ohm meter. Or this make, let us say, 1 or 2 ohm meter, or this particular make which is lesser than 1 ohm meter. Actually, the final values are similar. There is no big change. So again, this study report shows that the earth enhancing, the resistance of the earth enhancing materials are immaterial in improving the resistance. Now, IS3043. Point number 13.5, it talks about how to make the soil treatments, what are the advantages, what are the disadvantages. The final line you can see here, coke grease should also not be used due to its highly corrosive nature. If you use coke grease, of course, it will accelerate the corrosion. Now, actually, this subject, earth enhancing compound, is a very, very sensitive subject in our country. It's very sensitive in the sense, most of the time it's sensitive because manufacturers claim so many exorbitant stories. Imagine one manufacturer claiming, I have an earth enhancing compound produced in Dubai in a specialized environment, in a specialized area, which is wherever you put your earth resistance becomes 0.5. Another manufacturer claims, I brought it from Himalayas, so this is special. Another fellow says, I brought it from mid of the sea, so this is special. All these claims are there. Unfortunately, these are only claims. So the problem number one is the exorbitant claims of the manufacturer. Number two, non-awareness of the users believing the claims due to technical and commercial reason. Technical reasons, for example, most of the time, there is a problem, there is a fault, or there is a damage to the electronics, and the safety engineer or the person, say for example, you have an UPS has failed. UPS vendor will come and say that, sir, it is due to the higher resistance of the earth electrode. So you have to have an earth electrode of 1 ohm. It's a technical reason. Now, the client always try to reach 1 ohm. Technically, this is wrong. So such non-awareness is one of the reason. The third problem is you test one product, but you supply another product. And the fourth problem is lot of electrical engineers still believe that a chemical will appear, a chemical will be bound, which will save the electrical installation from all safety hazards. Absolutely, this is nonsense. So because of these reasons, if we talk about earth enhancing compound, you know, a lot of my presentations, I always say, more than making friends, I make more enemies after my presentation. It's a fact that in the name of earth enhancing compound, lot of claims. Some people claim that you put my chemical, all your problems are gone. Actually, this is wrong. The fourth one, why I put is a lot of people still believe that there can be a chemical which will solve all the problem. And what are those materials practically sold in the market? The first one, salt and charcoal, everybody knows it because it is there on the standard. The second one is a bentonite, which is a natural, a substance. Bentonite, it is a little bit less corrosive in comparison. The other materials which is used are actually coke flakes. How does it looks like? It's like it's a flake. Flake means maybe 2, 3, 4 millimeters of a small paper thick material having a dia of something about 3, 4 millimeters, black in color. And this coke flake is used as an earth enhancing compound. Probably the resistivity of that material is 0.12 meter or very much lesser, but actually it is highly corrosive. That is why we have written, it is written in the IS3043 that it corrodes. The second material which is cheaply available in the market is fly ash. You know, all of you knows what is fly ash. It is the waste from the thermal power plants. Kilogram probably is about 1 rupee. So you buy 25 kilogram, put it in a bag and sell it for 200 rupees. It's 25 rupees buying and 200 rupees selling. A good profitable business. But the problem is this is also a highly corrosive material. Most of the items sold in the market under the name of earth enhancing compounds are either fly ash or this coke flakes. There is nothing called a magic material. You can also use cement. Cement in the sense you use normal cement. This is also sometimes works very well. And you can also have the fourth material, conductive cement, less corrosive. Basically, these 5 are the materials which is used, out of which these 2, coke flakes and fly ash, these 2 are the commonly used material with a lot of stories and the resistivities are quite less. But the problem of these 2 materials is it corrode your electrode quite faster. Now, international practices also always, people always try to claim that, the IEEE 80, which is a very good standard, the IEEE, I will just stop the sharing and share it again because I'm getting the slides in my presentation is not moving. One moment. I'm sharing it again. I think now it will work. Yeah. So people say that, look, IEEE 80, a big one of the best standards on earthing, they explained that 0.12 ohms of material is available in the market. Now, to make a background, I'm just explaining what kind of standards are available from the standard publishing body. I'm just taking the example from IEC. IEC has got the international standards. That means it's a rule, technical reports, which is not of normative. It is not a rule. It is just for information. Technical report, also technical specifications. These TR and TS, if you see an IEC standard with the code TR or TS, you should understand that these are informative or these are actually supporting some of the standards. Similarly, in IEEE, the standards are classified into the standard to be produced can be either of a standard containing mandatory requirement, comma, a recommended practice outlining preferred procedure, comma, a guide offering suggestions. So there are 3 types of documents. Now I am showing you 3 IEEE standards. IEEE 80, which is a guide for the safety in AC substation grounding. So it is guiding to make something. It is not a mandatory requirement. It is not a recommended practice. IEEE 142 and IEEE 1000 are recommended practice. I go back, you see, IEEE mandatory requirement, recommended practices, and a guide. So the standard which is always referred in India for earthing and earth enhancing compound is the IEEE 80. Of course, it is one of the best guide which is available, which can be supportive to make an earth grid in soil in order to reduce the step and touch potential. No doubt about it. But the only point is, a lot of time people are using these techniques for earthing in low voltage electrical installation, which is absolutely wrong. Recently, I have seen a tender from railways, one of the largest project which is upcoming in India. They have a signaling and telecommunication installation. In a signaling and telecommunication installation, you can very well see that the application is only maximum 400 volt, and the all other rest of the installations are lesser than 400 volt. And they wanted to make earthing as per IEEE 80, which is absolutely wrong. Now, how this IEEE 80 is used, very important. In America, they have the high voltage distribution or medium voltage distribution, say for example, 25 kV. Whereas in India, we have a different system. How I got this particular information is, since I was working with this, BIS standards, every time there is a confusion and we have to try to clarify the confusion. So I have written to one of my friend, Dr. Abdul Mousa. He is a very senior scientist in, I think a lot of electrical engineers know him personally. So he is from Canada. So I asked him what exactly or how exactly the system works and how come the IEEE 80 has to be applied. Then he told that in North America, where IEEE originated, the distribution is usually 25 kV, and they have, every house has got a pole top transformer, and the IEEE 80 is not used there. It is used for 230/25 kV or 138/25 kV, or you see, these are the extra high voltage substations. That is the place where IEEE 80 is really used in America. But the problem in IEEE 80 is nowhere it is written the applicable voltage. The definition of substation is missing in the IEEE 80. About 2 years back, an IEEE delegation came to Delhi. There was a common seminar. I could talk to some of the, I made a presentation to all the participants. Then finally, we had an interesting discussion about IEEE 80. There was a delegation, and they told me that they will clarify my doubt, because I wanted to tell them very clearly that IEEE 80 is used in a wrong way in India. It is used for low voltage application. Why don't you make a help? You make a letter or something saying that IEEE 80 is not applicable for low voltage installation. Then the interesting is, this gentleman went back and he sent me a reply. I will ask my staff to forward the described situation of the IEEE 80 sponsor for consideration. It is against IEEE policy to offer interpretation on standards, but the sponsor can consider your comments in future revisions. The first information which I got from the reply, I think Mr. Sam is a senior person in IEEE, in the office bearer in IEEE. The first information which I got is, the sponsor, I will forward it to the IEEE 80 sponsor. Sponsor means somebody is sponsoring, or probably some committee is sponsoring this particular standard, and they have to decide whether to include a definition or not. So what conclusion from this is, in America, they have the substation, and the IEEE 80 is used in the substation, 66 kV/25 kV, for example. The touch and step voltage reductions are made there. Whereas when it comes to India, we use the same principles for a 11 kV or a 230 volt transformer. This is actually wrong. We are supposed to use it here at a substation, a transmission or a distribution substation. So what I wanted to tell you is, even though the earth enhancing compounds are written in several standards, please understand that behind is a reason, predominantly about the low voltage electrical installation in the sense a consumer premise, probably with a transformer 11 kV, 22 or 33 kV. Under that condition, these principles, the earthing explained in it is practically not applicable. This is what I confirm. Then what exactly you should do for a consumer premise? It is protective equipotential bonding. Protective equipotential bonding means you have to interconnect all the metal in your building in such a way that the touch and step voltages are lesser. Now, under that condition, you need an earth electrode in soil if you have a TT system, and this earth electrode resistance can be up to 1666 ohm. Let's say 200 ohms or 300 ohms, nothing happens. So if you have a TT system, you need to have one earth electrode in soil for the purpose of taking the fault current back. If you have a TN system, then you have a metallic connection back to the neutral of the source. So basically, we are talking about this earth electrode in soil. What I wanted to state is, in a consumer installation, in a consumer premise, the earth electrode resistance can be even a higher value of 100 ohms. Don't worry about it. You put a 30 milliampere RCD, your problem is solved. Now, the only application where you need a specific value of earth electrode resistance in a low voltage or in an industrial consumer premise is if you go for an earth electrode in soil, especially a type A earth electrode in soil. Then people ask, what is this type A earth electrode? Type A earth electrode means, as you can see in this particular picture, there is a building, there is one down conductor. Sorry, maybe on the other side there is one more. Every building should have minimum 2 down conductors. Each down conductor is connected to an earth electrode in soil, and these earth electrodes are either horizontal or vertical. Sorry, vertical or horizontal. Now, in soil, there are some calculations given in the standard. You have to put certain X length of the earth electrode in soil, and if you cannot put that particular X length, you are supposed to make resistance lesser than 10 ohm. So something like this, a vertical or a horizontal length. In large buildings, the recommended practice is to go for a ring earth. If you go for a ring earth, again, the earth electrode resistance is not very much important in a larger building. So basically, the earth electrode resistance of 10 ohm is necessary for a building where a type A earth electrode in soil is made. Now, to make the conclusion and the final part of the presentation, where exactly is required and what exactly is the background of this particular material and how come we started using it so extensively. Now, you know very well that for a low voltage consumer premise, if you go for a TNS system, earth electrode resistance is immaterial. If you go for a TNCS system, earth electrode resistance is immaterial. If you go for a TT system, it can be anything 1600 or 166 ohms depending upon your RCD value. For public distribution, if you have public distribution means the power supply company, they can have the HT side of the earth electrode a certain value in order to reduce the temporary over voltage in the consumer premise if they go for a TT system. And if you go for industrial system, actually the earth electrode resistance is immaterial. If you have your own transformer or if you have your own DG, and if these are within your control, very close to your premise, technically speaking, these are actually immaterial. The only place where you need a 10 ohm earth resistance is for lightning down conductor earthing, type A. Now, what is the background? In countries where the soil temperature is below 0 degree, imagine Russia or America or some countries where they have sub-0 degrees. In countries where the soil temperature is below 0 degrees centigrade, maintaining an earth electrode resistance of 10 ohm. Where is this 10 ohm required? 10 ohm is required for a type A earth electrode for a lightning protection system. So maintaining an earth electrode resistance of 10 ohm is difficult due to the inconsistent soil resistivity. What is this inconsistent soil resistivity? During summer, probably once when there is raining and once when there is a resistive soil moisture in the soil, the resistivity is 100 ohm meter, whereas during winter, peak winter, the same soil can offer you a resistivity of 10,000 ohm meter. So it is changing from 100 ohm meter to 10,000 ohm meter. It is drastically changing. Under that condition, if you use bentonite, which is nothing but the natural clay which is available abundantly from India, if you use bentonite all around the earth electrode, actually what happens is the bentonite is absorbing the moisture during summer, during rainy season. It is absorbing the moisture and it is keeping the moisture for a longer time. So as a result, the area all around the earth electrode is a little bit wet. As a result, the resistance what we are getting or what they are getting is lesser. So for application as per serial number 1, using bentonite is a very good solution to keep lesser values of resistance. So for countries where they have sub-0 degrees, means temperature very, very low, probably in India, this is applicable in Kashmir. So wherever the soil resistivity or wherever the temperature is minus degrees for a longer time, the moisture content is quite less. As a result, the value of the soil resistivity is going very much up. And if you have a earth electrode in soil under that condition for the purpose of lightning current dissipation, 10 ohm resistance, then you can use bentonite as an additive material and it really helps. As a result, what has happened is the only place in a standard where this material is recommended is IEC 62305, clause number 5.4.2.1. What is written is reduction of earthing resistance by the extension of earth electrode is practically convenient up to 60 meters. That means if you wanted to have a long earth electrode, you can do it up to 60 meters. Now the second line is in soil with the resistivity higher than 3000 ohm meter. That means if the soil resistivity is more than 3000 ohm meter, the use of type B earth electrode or earth enhancing compound is recommended. So this is the only place in an international standard where you can find this particular material is recommended. Where it is recommended? For lightning protection, where the soil resistivity is more than 3000 ohm meter, you use either a type B earth electrode or you use an earth enhancing compound. As I said, this predominantly this is written because the countries where they have sub-0 degrees, this material is actually helping them in making a resistance lesser than 10 ohm. But now to our situation, earth enhancing compound is required only for places where the soil resistivity is higher than 3000 ohm meter for LPS type A earthing. For public distribution, this may be useful for the utility company if they go for a TT system, interconnected system. Number 3, earth enhancing compounds used in industrial, commercial, and residential application in India, where the soil resistivity is lesser than 500 ohm meter, are helpful only in deteriorating the life of the earth electrode in soil. I read it again. The earth enhancing compound used in India in places where the soil resistivity is lesser than 500 ohm meter, they are helpful only in deteriorating the earth electrode in soil. It is never going to improve your system. A value of 10 ohm or 1 ohm or even 100 ohm, it doesn't matter in a low voltage electrical installation. A low value of 1 ohm is not going to save any electrical installation. This is the reason earth electrode resistance test is removed from the IS732. All of us knows very well that whenever there is a electrical safety audit, we first do is the earth pit resistance measurement. Actually, in the IS732 2019, this has been removed. You don't need to test it anymore for the purpose of electrical safety because it is not going to help you. So if you wanted to make a safety earthing, or if you wanted to make an inspection, then what you should do is you should measure the continuity resistance of the protective conductor. You should have an earth fault loop impedance and establish the disconnection time. You should have a touch voltage across simultaneously accessible parts, a lower value, low floor and wall resistance, main and supplementary protective equipotential bonding. You should have reduced circulating currents. These are the 6 parameters which is related to earthing. Earth pit resistance measurement, unfortunately, is immaterial. So, and as a result, since earth pit is immaterial for a modern day electronics, of course, the earth enhancing compounds are also immaterial. So with this, I would like to stop the presentation. I am sure that I have made a big, subject I could make in a short time. I don't know whether you understood or not. The video and the blog, the technical research paper that will be published in the blog of Solve, you can download it and you can understand it further. You can also ask question and we are ready to support you.
Thank you, Mr. Gopakumar. The blog, the link has been mentioned in the chat box. If you see, the Lakshmi has been typing it, and you can just share the link to your friends and understand the various articles written by speaker. And also, I've been requesting not to put a question in the chat box. We have Q&A. If you look below the screen, there is a Q&A box. Please mention your question with the name. The anonymous questions will not be taken. Wonderful presentation. We almost covered 1 hour 30 minutes. So 1 hour 30 minutes. We have 29 questions, and there are a lot of hands being raised to physically talk to Mr. Gopakumar. Let's see how fast we can cover maximum questions in this. And if we have a time, those who wish to talk to Speaker Gopakumar, please raise your hand. And those who raise the hand, I will try to put you on the speaker and you can ask this question. So that is one, when we finish certain questions that is already there in the box. We are almost 35 questions. So let me run through this quickly. Our regular participant, Nursing Rao Pujari, is asking a question. Okay, yes. Yeah.
That's about voltage drop. Actually, that is not today's subject.
Okay. Let's skip that. So we'll stick to the questions that is related to today's topic. So Vadi Venkatesh is asking, why am I getting shocked through my entire power supply is off? Why I'm getting the shock when my entire supply is off, and also have a proper earthing in building.
Yeah. The only chance is, normally this doesn't happen, but if you have a TT system and if the HT side of the TT system, the electricity supply company, if they have made the HT earthing and LT earthing separate, then there is a chance that in a consumer premise, during a fault at the HT side, a person at the LT can get a shock. There is a chance, but this chance is quite remote. This may not happen regularly. But to your question specifically, I really don't know. If there is no power, then how can you get a shock other than this?
Yeah, good question. So next to Dev Narayan, what is the good earthing value for transformer body, system earthing, lightning arrestor, panel board, and household equipment?
As I said, the earth resistance value is immaterial. Transformer neutral, or transformer body can be, actually you don't need to connect it to the earth pit if you have if you are an industrial consumer, if you are a electricity supply company, and if you are using a TT system, then probably depending upon your soil resistivity and the fault current, you have to assure certain value in order to safeguard your consumer from shock and failure. But that is, there are some calculations. You can refer to IS732 clause number 4.45. I mean IS732 clause number 4.45. You will get the answer. So the calculations are included there. It will be very difficult to answer, through a small session.
Yeah, most of the answers are already there in the slides that Mr. Gopakumar said. So some of the questions is already answered, but however, we'll try and see how fast we can do this. Karma is asking which earthing is useful for the public, and what is the international high of the earthing pit? So is there any standard for the international standard for earthing pit? What is the question?
There is no. Other than this lightning protection 10 ohm type B, there is no requirement of a specific value of earth pit resistance. So what kind of earthing is used? Yes, system earthing type, TNS or TNCS or TT.
Bishal is asking how to calculate that. I think you how to measure the.
Now, sir, distribution panel, what earth resistance value has to be maintained? Actually, as I said, the earth resistance value is actually immaterial. So I would prefer that this question, there are a lot of similar questions. We can avoid these questions.
He's asking what is the difference between electronic earthing and power earthing?
Yes, for electronic earthing, in order to maintain the functionality of your electronics, because in your electronics, you have a lot of equipment, those who are communicating in between. For a better communication, we are supposed to have a common reference point, which is called as functional earthing. So a functional earthing, sometimes it is also called as a clean earthing or isolated earthing. A separate earthing system is required, but this also has nothing to do with the earth pit and soil. You have to make it inside your room or inside your building and finally connect it to the same protective earthing system.
Okay, Arish is asking if 2 for body, 2 for neutral, or installation of multi electrode is wrong, then what is the proper way of install each electron? Earth electron, sorry.
Oh, I would say that rather than what is the proper way of installing earth electrode, I would say, what is the proper way of making the connection of neutral and body? Very easy. You take a bus bar, body of the transformer connect to the bus bar, neutral of the transformer connect to the same bus bar, and that bus bar you decide, depending upon your application, where to connect. If it is on a public distribution, to the earth electrode in soil.
Sir, Vadi Venkatesh is asking again, which is good plate earthing or pipe earthing?
There is nothing, both are good only. So probably you can go for a pipe or something like that.
Santosh Bhagade, does chemical earthing is maintenance-free earthing? Does it require pouring of water at regular interval? How pouring will affect the life of electrode, and in which case pouring of water is necessary or does it require?
The first question is, how does chemical earthing is maintenance-free earthing? I don't know. Everybody calls this as maintenance-free earthing, but then the question is, we should understand what is the opposite of it. What is the earth pit which require maintenance? Probably in the IS3043, the salt and charcoal is put, and probably people are pouring water in some earth electrode in order to get low resistance. And if you think that that is a system which require maintenance, then of course the earth enhancing compound is maintenance free. Actually, these wordings are meaningless. Does it require pouring of water at regular intervals? Not required, and anyway, even if you are pouring water or not, it doesn't matter. how poring will affect the life of the electrode. If you have lesser resistivity of the soil, of course, the chance of corrosion is higher.
Okay, Om Sri Krishna is asking, how can we know the condition of earth electrode to understand whether the electrode is corroded or not? How do we know?
Yeah, for that particular purpose, it is good to make a earth electrode resistance test. By making a test, you know whether it is there or not.
So is asking which type of earthing followed in domestic distribution, that is 11 kV and 440.
Yeah, the regulation says TMCS or TNS, but the utilities follow a combination of different systems. Confusing, very difficult to answer actually.
So Muralidhar is asking, can we accept chemical earth pits are acceptable by as per BIS? Sir, can you repeat? Did you answer?
No.
Okay. Answer is no to Mr. Muralidhar. So Srinivasan, what is the earth resistance allowed as per the standard for LV system? Is it the same for all the LV applications?
It is applicable for all the LV applications. The earth pit resistance value is not necessary for all LV application. Anything below 1000 volt AC or 1500 volt DC, this value is not applicable.
I'll call you back. Mr. Srinivasan, what is the earth resistance allowed? Okay, I'll go to Ganesh. What is the earth resistance allowed as per same? I think I'll come under different name, same question is coming. Anyway, I'll move to Santosh Vishwakarma. Which material?
Covered it.
Yeah, which material? You covered it, EEC. Again, Ganesh, what about the bentonite and macronite for improving soil earth?
As I said, you can use it as per it is mandatorily recommended if you have very high soil resistivity, say for example 3000 ohm meter. So practically, if we are talking about a low voltage system, the earth electrode resistance of, let us say, 1 ohm or 5 ohm or 20 ohm or 30 ohm or 100 ohm is immaterial. This is the point.
Binit is asking, so salt and charcoal should not be used as they highly corrosive to earth electrode?
Yes, of course. It corrodes the earth electrode.
Okay, I'll move to Santosh Vishwakarma. How cement is useful to reduce soil resistivity?
Cement is actually not reducing the soil resistivity. Cement actually acts like a protector for your earth electrode from corrosion. But under most of the condition, if the soil is wet, cement actually keeps the wetness for a little bit longer time. Because of the wetness in the cement or in the concrete, you will get a lesser value.
Vadi is asking how to know condition of earth electrode. What will be the typical life for GA and copper pipe and plate earthing?
Oh, these are there on the standard. You have to refer the IS3043. The approximate corrosion factors are given. Please refer IS3043.
Okay, Ganesh, is it okay? Is it need to check step and touch potential for LV system?
Not step, but touch potential inside your building, because between simultaneously accessible metallic parts, of course, yes, touch voltage need to be measured.
So what are the type A and type B earth electrodes?
Type A is a vertical or a horizontal rod or a pipe or a conductor in soil. Type B is a ring earth all around the building or a foundation earth. That means the steel inside the foundation is used as the earth electrode. That is type B.
Okay, Sriram, water will pour in the earth bit. If you use cement, it becomes rigid. What after that cement absorb water? Whether the same earth bit gives good resistance value?
Actually, the point which I am trying to repeat is this low resistance value is not at all necessary. Even in IS3043, it is written. So,
okay, question by Muralidhara is again chemical.
same
Earth-based
question.
acceptable BAS, we said no. Okay, Arun Kumar is asking, thanks for the insights, sir. Soil resistivity in India, less than 500 homes or greater than 500 homes. In PPT, you're showing more than 500 homes, but you have said less than 500 homes.
Oh, sorry for that. There can be some small mistakes. You know, once when you make a presentation, there are also some spelling mistakes. Thanks for noticing it.
Anyway, thanks for highlighting that, Arun. Okay, Anil Sonmane is asking transit. Okay, he's from transit. I'm Kunal. Most of the time, I see earth strip covered with sleeves laid up to earth beds. Is it good practice since it reduces connectivity to soil?
We cannot say that it is a good practice or a bad practice. Probably it is to protect the conductor from corrosion. So if you have a plastic sleeve, then your conductor is protected from corrosion. But if you wanted to have a lesser resistance, which is, as I said, not at all necessary, then you have to have an uninsulated conductor.
What type of earthing leakage is impacting electronic device for a system?
What kind of earthing leakage? Actually, an earthing, whenever there is a leakage current through the earthing system, technically speaking, your electronic system shall not have any problem. Now, for that particular purpose, your electronic or communication devices are supposed to have functional earthing or signal earthing, which is isolated from the protective earthing, and both protective and signal earthing are connected at a single point. By making a signal earthing or a functional earthing, the leakage current through the protective earthing system is not flowing through the functional earthing system. As a result, in simple, the protective earthing leakages in the protective earthing system are not supposed to influence your electronics.
Good. Ganesh, who's the fire officer, is asking, can we ask for earth certificate? Do we give earthing certificate or something?
No. Don't ask for it. It is not going to help you. You can ask for the complete test certificate as per IS732. Lot of tests are there. That will help, really. Help in stopping fire.
I think that's good information that you said now. Okay. Raghuveer, we are facing electronic components failure in large scale ground mounted solar PV plants. So large scale ground mount solar PV plants or PV plants. So what could be the reason, Gopakumar?
Yeah, without analyzing the reason, if I make a comment, it becomes wrong.
This
I
lead us
really
to
don't know.
a site study and give you the report.
Yes.
Yeah.
You can contact me. We can have a site study and then tell you the exact reason.
Yeah, if when he said contact me, everybody would have noticed Mr. Gopakumar's website and his mail ID is given in that chat box. People can write to him. And also, again, we have solve.co, solve.co. In that also you can put your questions. So Srinivasan, how much earth resistance homes value to be maintained for LV system and LPS system?
I would like to skip this question because this is what we are saying repeatedly.
Do we require a dedicated earth pit for DG set
diesel tank? Of course, wherever you have fuel, then in case of the electrostatic charges need to be reduced. You need to make a connection to the protective bonding system, not an earth pit actually.
So somebody is asking for definition of TT system. That's why I think we have done this couple of times.
It is quite difficult in a short time.
So JP Singh is asking, can we measure earthing resistant during or immediately after rain, and also snowbound area when snow has covered the entire area.
If the entire area is covered by snow, then we cannot measure practically. We have to measure above the snow, which may not be the correct way.
Okay, too many questions from Badi. Okay, let's go to Arun Kumar. Which is good for LA down conductor, insulated cable, or earth strip?
Oh, I don't understand the question.
Mhm.
Insulated cable or earth strip? I don't. Sorry, earth strip is actually used in a probably he's asking a strip or an insulated conductor. Both are good. Both can be used, but it is not like one down conductor. You need to have multiple down conductors. Several down conductors are required.
Okay, VSK Prasad is asking, is it mandatory to provide dedicated earthing for UPS system?
Absolutely no. This is one of the main reason for fire in office buildings. Officers have the habit of using a three-phase UPS. Output of the UPS is connected to single-phase devices, and the incoming neutral is used for the output single-phase devices. And at some point of time, the neutral is connected to an earth pit in soil. This is absolutely wrong.
So this Prakash Kumar is asking, who can we implement these nouns in our project when government body doesn't understand these practical problems? Did you understand this question, Gopkumar? I'm not able to understand this.
Yeah. What is actually the challenge of an electrical engineer to implement their modern system is most of the time it is due to the government body, such as the electrical inspectorate or PWD, CPWD and all, because they have still in their mind they have the system of this separate 2-4 neutral 2-4 body. Changing this concept itself is a big task, but we all of us know that it is wrong, and if we keep on making the mistake again and again and again, our buildings are going to be more vulnerable to fire and shock hazard. Why do we make dangerous buildings? At some point of time, we should tell them and we should bring them to our line.
Ullas is asking, as per petroleum rules, in addition to lighting protection system, 10 ohms requirement is there for grounding of hazardous storage facilities.
Actually, this is a subject which I don't want to answer, but still I will answer. There is a standard called as OISD, I think, Oil Industry Safety Directorate or something like that. They have written, this organization is somewhere near Noida. They have written a standard where they are asking to put everything separate. It's actually their book itself is against the basics of earthing. So if a technical book from an institute like the petroleum rules, if they are writing something wrong, how can I comment? And you have seen a video where the something like from the chamber fire or the explosions are happening.
I think, Ullas, you need to take it up with your department on petroleum. As Mr. Gopakumar says, it's wrong. Wrong standards have been followed. So Shivakumar Somasundaram, should we connect the diesel tank body earthing with panel body earthing?
Of course, yes. Equipotential bonding.
Suresh D, how to connect water pipelines of chilling plant to substation protective earthing system?
Oh, you have to take a wire and you have to make a connection. Now, how to make the connection and where to make the connection, you have to seriously look into the standard. There are rules how to make and where to make. You should follow the rules and make the connection.
Jay is asking, need to understand what value 30 or 300 milliamps of RCD to be used for a humidity sensor metal enclosure placed outdoor, exposed to rain and other environment conditions.
Humidity sensor. Of course, a sensor may not have this much current to trip. Probably if the sensor is also using a power line of 230 volt, then if you wanted to protect against a shock, you should use 30 milliampere. If you wanted to make only safety from fire or arcing or leakages due to fire, then you should use a 300 milliampere.
I think Mr. Vadi Venkatesh sir is asking too many questions. I think we have more than 9 to 10 from this. I will take last question out of you. Let's see our speaker can answer this. Is it mandatory to have insulators for earth strips which will run on horizontal and vertical portion of buildings for lighting protection? If yes, please share IS or IEC code.
It is yes, only from the point of view of corrosion. Imagine you have a strip which is on the surface of the building. The corrosion chances are higher. Instead, if you put a small insulator in between, the chance of longer life is more. From that point of view, yes, it is better to have an insulator in between.
He's asking is the IS or IEC code is available for that. Is there any?
No.
So Vivek Chaudhary, what is the best way to protect PLC in terms of any leakage if earthing is immaterial?
First, you should find out your PLC require a functional earthing or safety earthing. So earthing is classified into two types, safety earthing and functional earthing. First, you should find out what exactly is required for your PLC. If your PLC require a safety earthing, then that particular terminal of the PLC must be connected to the protective equipotential bonding of your building. That means the earth bus bar of your incoming power supply panel. If your PLC require a functional earthing, means it is the symbol 5018. That means in order to work properly, the PLC require a zero reference point. In that case, that particular terminal must be connected to the functional earthing system of your building. Both protective and functional earthing are separately running inside your building, and only at one place you should make a bonding. So the leakage is basically happening between the 230 volt or a live conductor and the earth, protective earth. To the functional earth, generally leakages are not applicable.
Thank you. Pratap Reddy, your fire access road are installed with many earth pit. Is it not obstructing on the object? So I don't know. The question is whether the earth pit which is installed on the road, which access for the fire truck, is it obstructing? Of course, it should be obstructing. And you have seen the image of what a video that is given. That itself is causing the fire. So I don't know. That is from fire experience. I'm saying about Gopkumar. You have anything on this?
Yes, this is again, as I said, there are several buildings with hundreds of earth pits all around the building. It is more than using this area as a road. Electrical safety of these buildings are in deep trouble. Chances of fire is much more. So more than road, that is the serious part I would consider. So
Pratap Reddy, you must be sure that it's wrong to have earth pit on road, basically. So that itself can cause fire. So you need to take real objection to this at your site. So Anup is asking, you said IEEE 80 do not mention the applicable system voltage presented mail communication with IEEE, but have IEEE team intimated that the standard will be revised by when the same can be expected?
Yeah, I have written to the management board of IEEE 80. They have replied saying that they will inform the sponsor of IEEE 80 to make modification. It is up to the sponsor to accept or not. When the revision will come, actually, this is not in my hand. Most of the time, they are not going to consider this modification, because if this modification is, in people in America knows the meaning of substation. So, and this standard is existing for several decades. The problem for India is our people are reading it and using it in a wrong way. That has nothing to do with the standard making body. That is our problem. We have to correct actually. Why I showed the emails are, yes, of course, the subject is known to them. It is brought to their attention and probably they will take it up further. And when and how, I really don't know.
I think the subject for 1.5 hours is not sufficient for the subject that we are covering. And I'm seeing the questions are increasing, every second. So we are still have 42 questions. What I would recommend is it's already 101 and we had 350 attendees and even the attendees count is also coming down. So I would recommend that those questions that not been answered, please Lakshmi will type the email ID of Lakshmi. Lakshmi, you can take the questions, or Mr. Gopakumar mail ID can be mentioned there. So and we can also take up because it's on record. So these questions are with us. So we'll individually we will try and reply to all these questions as much as possible, and we've been doing that. But in these sessions, we have not many questions, though it is simple, but it's important to address each one questions there. And we have a time limit here. And as you know, Mr. Gopakumar need to attend one more webinar at 3 o'clock. So we have time issues here. So I would request everyone to join us for the next webinar that will happen in June. I have recommended Mr. Gopakumar to take up the subject on learning from losses. So there are a lot of electrical short circuit that happened, and recently there are a lot of fire. Why it is happening and how we can control, and what kind of losses that we are talking about. Not only the human loss, what is the economical loss? What is the financial implication of those losses for simple ignorance or not practicing the safety standard or electrical safety standard, but what kind of losses are we talking? So let us be more practical in our next session and to say, small compromises, small ignorance, chalta hai attitude, it does not going to happen to me because I'm living in this building for 15 years, but yet, you face this accident and final causes again electrical shock. So let's, again, it's my appeal to the speaker, Gopakumar, if we can have this, it'll be wonderful, because this is a topic that everybody is asking, what kind of losses that we're talking. So let's try and see. We'll come back again in the month of June, and everybody, we will personally write to you with the link to register. And also I appeal, because these are the free knowledge that we are sharing. Please invite your friends, colleagues, and who are responsible to maintain the building or responsible in handling this project. And I would request everyone to go through our website called Solve, SOLV, Solve LV, low voltage, .com. And it's a very, very interesting a website that they have created that can help and solve many issues that you have at your sites and projects. It's a tool that you can measure and we can do audit. And thank you, Mr. Gopakumar, for sparing such a wonderful time and off days gone in educating and creating awareness on this. I'm sure this will reward you in many ways. And we look forward to see you again in the next webinar in the month of June. And also I would appeal again, all the participants, do join us and keep sharing your thoughts. And also, if you think the subject that we have not covered, those who want to see our previous videos, previous webinars, please write a mail to us. I just shared to a couple of people. We have almost done 10. Our videos are available on YouTube. I can share you the link, and also I'll put it on our blog there. You can click and understand. And we
Mr. Dominic, I wanted to add here, all the webinars which we are making, it is available in the Solve blog. There, not only the videos, the question answers, the answers for these questions are also filled and put on the blog. So you can also find the answers. So please look into the blog.
Yeah, we have just typed the blog link there, solve.com/blog. So as Mr. Gopkumar said, everything is available, videos available, question and answer for previous one is available. So do share it with your friends and look forward to see you again. You all have a wonderful weekend and stay safe. Thank you, Mr. Gopakumar. Hope you enjoyed this session as everyone enjoyed this session today. Thank you very much. God bless you.
Thank you. Thanks for all. Thanks for all. Thank you, Mr. Dominic.
Thank you. Bye-bye.